Welcome to today's deep dive. We're going to be looking at a new study that uses AI to detect intervertebral disc disease in dogs.
Interesting.
IVDD.
Yeah.
It focuses on a deep learning model that analyzes X-ray images to identify narrowed intervertebral disc spaces.
I see.
These narrowed spaces, are a major indicator of IVDD.
Yeah, makes sense.
The study used a pretty substantial data set, actually. X-ray and MRI images from 142 dogs, spanning 27 different breeds and a wide weight range. So we're going to unpack how this model was developed and tested, its accuracy, and what this could mean for diagnosing and treating IVDD in our furry friends.
All right, sounds good.
That's Sue.
This is really cutting-edge stuff.
Yeah.
What's particularly exciting is that this model aims to bring a new level of objectivity and accuracy to the diagnosis of IVDD. Traditionally, diagnosing IVDD involves a combination of things, clinical signs, neurological exams, radiography, and MRI. But even for experienced vets interpreting these findings, especially X-rays, can have an element of subjectivity.
Yeah, for sure.
So this AI model aims to offer a more standardized and reliable tool to help with that process.
So how do they go about developing and training this AI model?
Well, they used a data set of 241 X-ray images from 142 dogs. And to train the model, a team of veterinary clinicians carefully labeled each image. They identified the vertebral bodies and then marked each intervertebral disc space as either normal or narrowed. This process, it's called manual segmentation. And it's the foundation for supervised machine learning.
I see.
It's like showing the model a bunch of labeled examples so it can start to understand the patterns and make its own predictions.
That makes sense.
Yeah.
So it sounds like they put a lot of work into teaching the model to recognize these narrowed spaces.
Yeah, they did.
What's the next step in this process?
They needed a way to quantify the narrowing to actually measure that distance between vertebral bodies based on the pixel measurements in the X-ray images. They did this with a pre-processing algorithm that estimates a curved line connecting the centers of the vertebral bodies and measures the pixel distance between them.
Interesting.
This approach cleverly accounts for the natural curvature of the spine, ensuring that the measurements are accurate.
I see.
So the result is a vector of pixel values for each intervertebral disc space, essentially translating the image into numerical data that the AI can work with.
So it sounds like a pretty sophisticated approach to measuring these tiny spaces on an X-ray.
It is.
So how did they use this data to actually train the model to detect narrowing?
Well, they employed a type of neural network called a large-kernel 1D CNN.
A what?
A large-kernel 1D CNN. It's a specialized neural network, particularly adept at comparing each intervertebral disc space with its neighbors, which leads to more accurate detection of narrowed areas.
I see.
This is a really smart choice of architecture because a traditional CNN, which analyzes images in small patches, might miss the subtle variations in disk space narrowing that are so important in diagnosing IVDD.
So how well did this large kernel 1D CNN model perform? Did it actually live up to the expectations?
The results were incredibly promising. The model showed a high level of agreement with the assessments of veterinary clinicians, achieving a sensitivity of 81.5% and a specificity of 95.6% in detecting narrowed intervertebral disc spaces.
So in simpler terms, sensitivity refers to the model's ability to correctly identify true cases of narrowing. While specificity measures its ability to correctly identify those that are normal. These results indicate that the model is highly accurate at both detecting narrowing and avoiding false alarms, which are critical for making sound clinical decisions.
Absolutely.
That's impressive.
Yeah.
But how did these findings compare to the gold standard of IVDD diagnosis?
MRI.
That's the burning question.
Yeah.
The study did find moderate agreement between narrowed intervertebral disc spaces identified on X-rays by both the model and the clinicians, and those confirmed by MRI.
So it sounds like this deep learning model has the potential to be a valuable tool in diagnosing IVDD.
It does.
But is it a replacement for MRI?
No.
Or even a veterinarian's expertise?
Not at all. There's an important caveat here.
Okay.
Certain discs, specifically the T10, T11, and L5, L6 discs, often appear narrowed on X-rays.
Yeah.
Even in dogs without spinal cord compression.
I see.
This means that a narrow disc space alone
doesn't necessarily equate to clinically significant IVDD.
So what does this mean for using this model in practice? It sounds like we can't just rely on the AI's findings alone.
Exactly. This study really underscores the importance of a holistic approach to diagnosis.
Right.
Veterinarians still need to consider the dog's age, breed history,
of course,
clinical signs, neurological exam findings, and imaging results, including MRI in some cases to get a complete picture.
Yeah.
The AI model is a powerful tool that can aid in the diagnostic process. But it doesn't replace the expertise and judgment of a veterinarian.
It sounds like this deep learning model could revolutionize how veterinarians approach IVDD.
It could.
But it's not a magic bullet.
No.
We'll need to keep refining the technology and learning how to integrate it effectively into veterinary practice.
Absolutely.
Where do we go from here?
Well, the study did point out some limitations.
Okay.
The sample size was relatively small, and there's a possibility of inaccuracies, particularly in analyzing off-center regions of X-rays. Additionally, they acknowledged that the model's accuracy could be affected when analyzing, those tricky off-center regions of X-rays.
Yeah.
Further validation with larger, more diverse data sets is definitely needed.
Okay.
Yeah.
So this is just the beginning.
It is.
There's still a lot of work to be done before we see this technology routinely used in veterinary clinics.
Yeah.
But it's incredibly exciting to see AI making its way into the world of veterinary medicine.
It is.
Let's move on and discuss some other interesting findings from this study.
Okay. One fascinating aspect of the study was its focus on the distribution of narrowed intervertebral disc spaces, both in the X-ray images and the MRI scans.
Makes sense.
They analyzed which specific disc spaces were most commonly identified as narrowed.
So it'd be interesting to see if there were any patterns or trends in where these narrowed spaces tend to occur.
Yeah.
What did they find?
Well, there are some interesting observations.
Okay.
In the X-ray images, the T10, T11 disc space was the most frequently identified as narrowed, followed by the L4, L5, and L5, L6 spaces.
So those are the areas where we might expect to see IVDD most often.
Not necessarily.
Wow.
When they compared these findings to the MRI results, a different pattern emerged.
Interesting.
The MRI scans actually showed that spinal cord compression was most common at the T12, T13, and T13 L1 levels.
Okay.
In the lumbar region, the L1, L2 level was the most frequent site of compression.
That's a bit surprising.
Yeah.
It seems like the X-ray findings and the MRI results don't always match up perfectly.
Right.
What about that T10, T11 disc space that was so commonly narrowed on X-rays?
That's where it gets really interesting.
Right.
Despite frequently appearing narrowed on X-rays, the T10, T11 disc space didn't show a high incidence of actual spinal cord compression on MRI.
So why might that be?
Well,
why would a disc space appear narrowed on X-ray but not show compression on MRI?
That's a great question.
Yeah.
Remember, intervertebral disc space narrowing can occur as a normal age-related change, even without any clinical signs of IVDD.
Right.
The T10, T11, and L5, L6 discs in particular are known to often appear narrower than adjacent discs in dogs, even in healthy individuals.
So it's not just about seeing a narrow disc space.
Yeah.
It's about understanding the context.
Exactly.
How does this impact the way veterinarians interpret X-ray findings in dogs suspected of having IVDD?
It really highlights the importance of a comprehensive approach.
Okay.
Veterinarians must consider the dog's age, breed, and overall clinical picture when interpreting X-rays.
Okay.
A narrow disc space alone doesn't necessarily mean the dog has clinically significant IVDD.
So it's not a simple yes or no answer.
Right.
It's about putting all the pieces of the puzzle together.
Precisely, this study underscores the need for a holistic approach to diagnosis, taking into account all available information, including the dog's history, clinical signs, neurological exam findings, imaging results.
This AI model can be a powerful tool?
It can.
But it's not a replacement for a veterinarian's expertise and judgment.
Absolutely. The AI can provide valuable insights and potentially speed up the diagnostic process, but it's essential to use it as a complementary tool, not a substitute for a thorough clinical evaluation.
It sounds like this AI model could be a real game changer in terms of efficiency.
It could.
Did the study look at how long it took to analyze the images?
They did.
Oh?
And the speed at which the AI can process information is remarkable.
Yeah.
The study found that the deep learning model could analyze an image and identify narrowed disk spaces in a fraction of a second.
Wow.
Compare that to the average time of 12.2 seconds.
Right.
It took a veterinary clinician.
That's a significant difference.
It is.
Imagine the impact that could have in a busy veterinary practice.
It could be huge.
Yeah.
This time-saving element could be especially beneficial in high-volume settings or emergency situations where quick decisions are crucial.
Makes sense.
It could free up veterinarians to focus more on patient care and other complex tasks.
But we also need to be aware of the limitations of this technology.
Of course, no technology is perfect.
Yeah.
As we mentioned before, the study had a relatively small sample size.
Right.
The authors also acknowledge that the model's accuracy might be affected when analyzing off-center regions of X-rays.
And they primarily used low-field MRI in this study.
Right.
Which might not have the same level of detail as higher-field MRI.
Exactly. There's always room for improvement.
Right.
The authors emphasize that this study is just a starting point.
Okay.
More research is needed to fully validate and optimize the model's performance.
Okay.
They recommend training the model on a larger, more diverse data set, encompassing a wider range of breeds, sizes, and body conformations.
Makes sense.
And ideally, using higher field MRI for comparison.
So what's next? What are the future directions for this research?
The researchers have some really intriguing ideas. They propose integrating this model with other AI-powered tools that can automatically segment vertebral bodies and detect spondylosis deformans.
Interesting.
Imagine a fully automated system for IVDD diagnosis.
That sounds incredible.
It does.
A more comprehensive and automated approach to IVDD could revolutionize the way we diagnose and manage this condition in dogs.
The potential benefits are immense.
Yeah.
We could see earlier and more accurate diagnoses, more tailored treatment plans, and ultimately improved outcomes for our canine companions.
That's the crux of the matter.
It is.
This research is more than just a technological advancement. It's about improving the lives of our beloved companions.
Exactly.
This research opens up so many exciting possibilities.
It does.
Where do we go from here in terms of translating this research into real-world clinical practice? That's the real challenge, isn't it?
It is.
Bridging the gap between exciting research and practical application.
Absolutely. This study has laid a solid foundation, but there's still work to be done. We need to continue refining the model, validating its performance in diverse clinical settings, and addressing the ethical and practical considerations of integrating AI into veterinary practice.
It sounds like a multifaceted process.
It is.
What are some of the key steps involved in translating this research into a tool that veterinarians can use in their everyday practice?
First and foremost, we need more robust validation. This means testing the model on larger and more diverse data sets, including a wider range of breeds, ages, sizes, and even different imaging equipment. We need to be confident that the model performs accurately and reliably in a variety of real-world scenarios.
So it's not just about proving that the technology works. It's about making sure it works consistently across different populations and clinical environments.
And beyond validation, there's the challenge of integration. How do we seamlessly incorporate this AI tool into the existing workflow of a veterinary practice? How do we ensure that veterinarians are comfortable using it and interpreting its results?
It sounds like training and education will be essential for veterinarians to embrace this new technology and use it effectively.
Veterinarians need to understand the model's capabilities and limitations. They need to know how to interpret the AI's findings in conjunction with other clinical data to make informed decisions about diagnosis and treatment.
It's a shift in thinking, isn't it?
It is.
Moving from a purely human-driven diagnostic process to one that's augmented by artificial intelligence.
And it's important to emphasize that this AI tool is not meant to replace veterinarians.
Right.
It's meant to enhance their capabilities,
Okay.
to provide them with another layer of information to aid in their decision-making.
Yeah.
Ultimately, the veterinarian remains the expert,
right,
responsible for evaluating all the data and making the best choices for their patients.
It's a powerful reminder that technology, no matter how advanced, should always serve to complement and support human expertise,
right,
not replace it.
Exactly.
What about the ethical considerations? Are there any concerns about using AI in veterinary medicine?
Ethical considerations are always paramount when introducing new technologies, especially in healthcare.
Yeah.
One key concern is ensuring that AI is used responsibly and transparently.
Right.
We need to be clear about the model's limitations, avoid over-reliance on its findings, and always prioritize the well-being of our patients.
So it's about striking a balance.
It is.
Embracing the potential benefits of AI while being mindful of its limitations,
right,
and ensuring that it's used ethically and in the best interests of our animal patients.
That's the burning question.
Yeah.
And as AI continues to evolve, we'll need to have ongoing discussions and careful consideration about its role in veterinary medicine.
Makes sense.
But the potential is certainly there to transform the way we diagnose and treat IVDD and ultimately to improve the lives of dogs suffering from this debilitating condition.
This deep dive has been incredibly enlightening.
Good.
It's clear that AI has the potential to revolutionize veterinary medicine.
It does.
Not just in diagnosing IVDD, but in countless other areas as well.
It's an exciting time to be in this field.
Yeah, it is.
And as these technologies continue to develop, I'm confident that we'll see even more remarkable advancements in the years to come.
It will be fascinating to witness how AI shapes the future of veterinary medicine.
It will.
And from Vet NeuroJar, keep those minds inspired, hearts light and tails wagging.